Good Lord, ride all the way.
A 10,
9,
8,
7,
6,
5,
4,
3,
2,
1.
Hello and welcome to Slooh, especially Slooh members watching on the live channel. Don't forget you can snap images using the StarShare camera below the show's video panel, and you can also chat. Use the chat box to ask us any questions during the show. So what are we doing tonight? Well, have you ever looked up into space, staring out at those countless stars in the night sky and wondered whether or not we're alone in the universe? Who hasn't? Have you ever maybe thought about how our own little corner of the galaxy, whether or not we're the only ones there, and if there were other solar systems out there, other planets, just like our own, way out there? Well, you're not alone in your wonderings. In fact, there's a whole section of astronomy devoted to finding these planets. And that's what we're focusing on tonight. You know, we've teamed up tonight with our friends at Astronomy Magazine to bring you the live images of a number of distant stars currently being orbited by known exoplanets. How cool is that? So obviously a big welcome goes out to Astronomy Magazine readers as well watching the Slooh show tonight, and you can ask questions actually by tweeting to @Slooh, or just send us your comments, or if you've got any of your own images that you'd like to share with us, just use @Slooh. Now, those live views are coming to you tonight from our flagship observatory here at the Institute of Astrophysics of the Canary Islands. And first of all, you can see this. This is our all-sky camera. This is the camera that members use to check out sky conditions. And you can see there, it looks pretty blue, doesn't it? Well, it's not the moon. Sorry, it's not the sun. It is the moon, making that a really, really bright sky tonight. So not very good, really, for deep sky objects, galaxies and nebulae tonight, but okay for our purposes to spot some of these stars and actually some planets as well. Anyway, as of the 1st of June, we've discovered 3,422 exoplanets orbiting, I think it's 2,560 stars since 1988. A little over a month ago, on the 10th of May, a staggering 1,284 new exoplanets were announced, discovered by the Kepler Space Telescope team. That's absolutely astonishing. So we've got quite a big choice as to what we point the telescopes to tonight. But anyway, there is the all-sky camera. So this is giving us this 180-degree field of view over the entire sky. You can see the telescopes down there on the left-hand side. The bright object to the right is the moon. That's going to be setting in about an hour or two's time. And you can also see there was Saturn and Mars in there as well. And this is a fabulous shot. These are live cameras, security cameras that are actually set up there, looking from the very top of the mountain. So we're at the Institute of Astrophysics, as I say, and this is on top of an enormous volcano. It's Mount Teide. It's the island of Tenerife, and it's 8,000 feet up in the air. And you can see we're above the clouds tonight. Isn't that cool? The big telescope on the right-hand side, bottom right of that, that's the optical ground station telescope. Fascinating instrument. That's one that members sometimes see the laser pointing out at. Now, what else have we got tonight? We've got our constellation cam tonight, and that's pointing to a really interesting area of sky. It's actually pointing to the constellation of Sagittarius. And there's one particular, we've centered this on one particular star which has an exoplanet around it, and we're going to be talking about that a little bit later with one of our experts. And then to illustrate some of our talking points tonight, we're going to have some live telescope views of our own moon and Saturn and Mars as well. And then in our half-meter telescope, that's the half-meter telescope that Slooh members use every night, we have got a couple of stars with some very, very special, and here's the first one. This is a half-meter telescope. There's the star right in the middle of that. We'll talk a little bit more about it later on, but that was actually the first extrasolar planet discovered and confirmed in 1991, I believe that was. There's some discrepancies actually about which one is the first one. But anyway, keep an eye on those. And don't forget, you can use the StarShare camera to snap your own images of that. We're going to be talking about whether or not we can actually see the planets tonight as well. So stay tuned for that. Now, throughout tonight's show, we're going to be talking about the various ways scientists hunt down and study these different exoplanets with Slooh astronomer Eric Edelman. We'll also be talking to Michelle Kunamoto. Now, you've probably read about her. She's made international headlines recently after she discovered 4 potential exoplanets. Well, I've just told you all the stats, and you might be thinking, well, okay, what's so special about that? But she's still an undergraduate when she discovered these things. So can you imagine discovering new worlds before you're even out of college? How cool is that? We're also going to get our comedy on a bit tonight as we sit down with Roger Phillips. He's the creator of the webcomic, The Grey Zone. We'll point you to that a little bit later on. We'll talk to him about his comic and why he thinks aliens have become the subject of so many different aspects of popular culture. I'm really looking forward to that interview. It should be a great laugh. And we will be wrapping up the night with Slooh astronomer and Astronomy Magazine columnist Bob Berman, along with Eric, as we sit down for an informal and interactive discussion about our own belief, or lack thereof, in aliens and maybe even UFOs. So make sure you send the panel your thoughts to @Slooh or use the Slooh chat feature if you're watching on the Slooh Live page. Now, to get the conversation started, I am delighted to welcome Slooh astronomer Eric Edelman to the show. Eric, many thanks for joining us tonight.
Hi, thanks for having me, Paul. It's great to see you.
And you. We should do this more often. Now, Eric, you bring a huge amount of knowledge about exoplanets to the show, because didn't you specialize in exoplanets while you were at college?
Yeah, exoplanets is pretty much my favorite part of astronomy to talk about. Like, really, that was where I did all my research and things like that. So,
Right.
yes, when it comes to exoplanets, I'm super passionate about it. I'm happy to be involved in this talk.
Well, we've got a whole bundle tonight set up, and you've got some of these lined up. But let's start off with a real basic. What is an exoplanet, basically?
And that's a good question. And it's something that, in terms of the specifics, some people still debate exactly what's going on there. But really, when you get down to the brass tacks of it, it's about a planet that is around a star other than our sun, something that is
Okay.
strong enough to have its own gravity, sort of, it's going to be sort of a sphere-like object, but it's also not going to be too big that it can get to the area of stars, start fusing, start having light of its own. So not too big, not too small, and not around our sun tends to sum it up.
Okay, so we're kind of using the same definition as a planet in our own solar system. So little Pluto obviously doesn't get that any longer. But so it's that same definition, but round a star other than the sun.
An extrasolar planet.
So yeah, and you use that term. Now, is this term extrasolar planet and exoplanet used interchangeably?
Uh, in the crew, in the exoplanet crew, it tends to be that we do combine. Most of the time, I do hear people when they talk about extrasolar planets using the term exoplanets. I guess it's hip with the kids these days. But of course, people will understand what you're talking about when you use this term extrasolar planet as well. So everybody's
Okay.
welcome to use the term they choose, I'm sure.
Okay, well, we'll stick to exoplanet tonight. Now, before we kind of talk about some of these ones on the screen, and also before we talk about how we discover these things, there's a kind of more fundamental question, and that is, why do we want to study them? Why is it important?
I think, and that's something that I think all astronomers have to grapple with, and people that are excited about worlds other than our own have to grapple with at some point in time. And personally, I think that there's two different really strong reasons that we do so. And one of them maybe being the one that's in the news a lot, trying to find that ET, trying to find life outside of ourselves, seeing what's out there in our own galaxy. But then at the same time, I think there's ways that we can look out at the universe to discover a little bit more about ourselves, about where we belong, if we are the only type of life like this out there in the galaxy, if there is something like us around there, if there are planets like our planets in the solar system, and is our solar system going to be one in a million, one in a billion? Is there never going to be
Yeah.
anything like us out there, or are we going to find similarities? Are we going to find ourselves in the stars? I think that's a question to ask as well.
So it's really helping us with our own place, identifying our own place in the universe, and this is what so many of us get so excited about when we think about astronomy. And it's almost spiritual when you start thinking about the numbers, the vast distances involved, and what we're coming up with now. I went through those statistics. We can virtually point to any star now, and there's a pretty good chance that there's a planet of one kind or another orbiting it. So how do we go about actually discovering these worlds? Can we image them directly?
That is one way that we can actually do it. It's actually not the most popular way that we have to discovering exoplanets, just because it's a very difficult technique to use, but it's what's called direct imaging, where it's what you do like when you're taking a picture of your friends, a direct snapshot of something. But the really big challenge about directly imaging an exoplanet is because what you were just talking about earlier, actually, Paul, is that we have the moon in our night sky right now, and so it's blocking out a lot of the light that we're seeing from other stars. In the same way, if we're trying to take a picture of a planet around another star, most of the light that we're going to see is from that central star. It's just going to pretty much saturate out everything else. And so one of the ways that people try to directly image planets is they try to attempt to block out that light from the central star, and also try to look in wavelengths where that planet will be emitting the most light. And so most of the times when we're directly imaging planets, we're finding planets that are really, really far away from their host stars, really distant. So we have a little bit of space for that light to just filter out a little bit, and also finding pretty big and warm and relatively new planets as well, because they're so warm. That's when they're first starting to form.
So, if we just hop back actually to that previous image of, we're showing live the star HD 114762, isn't it? All these lovely user-friendly names. We love those, don't we? So there we can see it, that star in the center. It's, what is it, 132 light years away from us. And we can see exactly what you were describing there. The star itself is kind of bloated because it's so bright in the image that, any planets are so close to it that they're just caught up in that. I love the analogy of that, the moon in the sky and it blocking out everything else. But it's not the only way. And as you say, it's actually quite a difficult way because of, those limitations that you've said. What are the other ways that have made discoveries? Are there other methods?
Well, since we're on HD 114762, what a mouthful, why don't we talk about the way that was discovered, actually? Because I believe they used what's called the radial velocity method to discover the planet around that star, that first planet. And so what the radial velocity is meaning, so velocity being sort of the speed that something's moving. So when we think about our own solar system, we think of our sun and then the 8 planets that are orbiting around it. But that's actually a little bit of a simplification, because what's actually happening is that the sun, as well as those planets, are orbiting a single center of mass. But the more massive the object, the closer that center of mass is going to be to it. So that center of mass in our solar system is really close to the sun. So it almost doesn't look like the sun itself is moving. It's orbiting a little bit around that major center of mass. And so other stars and planets around them have that same relationship. And so what we'll see often is that a star will sort of be wobbling around that center of mass, that a planet will be pulling it in different directions. And you can think about this like you're having an ambulance come towards you. You hear the sound be a little bit more high-pitched when it's coming towards you, and then a little bit lower pitched when it's going away from you. In just the same way, sort of the light shifts as we can see it from our telescopes when the star is coming a little bit toward us and when it's coming a little bit away from us. And based on how much that light is shifting, we can say, oh, a planet of this mass has to be pulling this star this much out of its way.
Right. Okay. So, if I get it right, you've got the star and you've got the planet here, and when it comes in front of us, it's they're kind of it's moving the star back and forward from our point of view, and that's what we're measuring. We're measuring the way that light is stretched, and you called that the radial velocity method. Is that right?
Yes. Yeah.
Okay. But there's another one as well, and that was the first method, wasn't it? The radial velocity was the first method, and in fact, that star that we're showing, I believe it was the very first extrasolar planet discovered using that method, wasn't it?
Oh, in terms of the other method that's available, right?
Well, this one. So HD 114762. This was the first one discovered using that radial velocity.
Yes, in terms of radial velocity, that was in the 1980s.
In the night, wow. And that was confirmed in something like 1991 or something. But there's this other method as well, which has actually turned out to be probably the most productive, hasn't it?
Yeah, so if you're looking at how many planets are discovered every year, radial velocity method, the planets discovered that way were dominating. They were pretty much the planets that were coming out until about 2010. And then all of a sudden, we get to the launch of what's called the Kepler Space Telescope, and then the transit method, which you're seeing right here on your screen, comes full into view. And so what the transit is, like remember earlier on, you might have seen this on Slooh, the transit of Mercury appeared in our own solar system, where we saw Mercury crossing over the front of our sun in our view. It made this black dot across the surface of the sun. And this is something that happens in other systems as well. We can look out into the galaxy and see different stars and see planets crossing in front of them. We don't get the clarity that we do with our own solar system. So what happens is we actually see that there's a certain amount of light coming from a particular star. But then once that planet comes along and is that black dot across the surface of that star, then the amount of light we're seeing coming from that star dips, and we get what you can see here, what is called a transit light curve. And so the light dips down while the planet is in front of the star, and then the planet gets away from that front of the star, and you resume seeing that normal amount of light that you would see from that star. And so that's what it is, the transit method.
As you say, that took off because of the Kepler Space Telescope, and that remarkable announcement, at the beginning of the month. I mean, to add suddenly nearly 1,300 new extrasolar planets that we didn't know about. I mean, it's absolutely astonishing. So we've discovered all of these exoplanets. How many types have we found? Have we found, they're all the same, or are they like our own planets, Jupiter, Saturn, Earth, maybe? What are they like?
And, we had no expectations, I don't think, when we were looking out and first trying to find other exoplanets. All we had to go off of was our own solar system and what we're familiar with. And right off the bat, we kept finding things that really, really defied our expectations with our own knowledge of the solar system. There were different types of planets that we'd ever seen before. And one that particularly came up when we started finding the first exoplanets. These were sort of the easiest to be able to find, were the hot Jupiters. So what that means is it's like a Jupiter, it's a giant gassy planet, and it could be something like 10 times the mass of Jupiter. These can be really big, and at the same time, they're also really close in to their host star. They can be orbiting closer in than Mercury orbits its sun. I believe you're going to see 51 Peg, which is a great example of a hot Jupiter, later on in the show, going to be going live to that system. And that's just one of many. There's also super Earths, but I could go on and on. Let me know if I'm rambling here, Paul.
No, this is interesting. But the methods that you've described there, presumably these larger planets are the easiest to find. So is there this thing called observational bias? The vast majority of those that we found are these very large gas giants, aren't they?
Absolutely. I mean, because in the beginning we were mainly seeing these big planets because For example, with the radial velocity method, the more massive the planet is pulling on that star, the more you're going to see that star move. And so it's easier to detect larger, closer in planets. Same with transit method. It's more likely that you're going to see a bigger planet cross in front of a star than you are going to see a smaller one. So in the beginning, a lot of our index of planets was populated with hot Jupiters. And then we started to discover more and more planets at different sizes, and we actually learned that hot Jupiters are sort of in the minority, even though those were the ones that we were mainly finding in the beginning. We were actually finding that planets closer to Earth in size, or maybe a little bigger, super Earths, like 4 or 5 times bigger than us, are some of the planets that we will expect to dominate our galaxy and the other stellar systems out there.
Okay, well, we will talk more about that when you're going to come back and you're going to be joining us with Bob. Bob's going to be on the show as well. So we'll have a sit down and maybe talk more about that family of exoplanet. And, you know, because that starts bringing up the conversation. You know, we know that hot Jupiters aren't very good to live on, but maybe some of the smaller rocky ones, you know, will be. So, Eric, thank you very much for that bit of a 101 on exoplanets, and we'll see you a bit later. That was Slooh astronomer Eric Edelman. By the way, if you haven't done so already, you have to catch Eric's weekly show, Down to Earth. It's always packed with fascinating info and it's great fun to boot. Now, we will also field some questions and discuss any comments from viewers. So if you have anything you'd like to ask us, just tweet them to @Slooh or use the chat box next to this show on the live channel at slooh.com. We are going to take a really short commercial break now, but coming up next, we are going to be sitting down with Michelle Kunamoto, an astronomy student who recently discovered 4 potential exoplanets while still an undergrad. Just how cool is that? But first, to viewers tonight joining us from the Astronomy magazine, if you're enjoying what you're seeing and hearing tonight, we really want to encourage you to become a member of the Slooh community. It's free to try and there's absolutely no obligation. You know, at its core, members control our robotic telescopes, both here in the Canary Islands and the Chile Observatory, via a simple but powerful interface to see just about everything that glows in space. In fact, Slooh members have taken well over 4 million photos of over 50,000 different objects in the sky. And I also checked the other day, and we are a whisker off delivering 100,000 FITS files to Slooh members so far in 2016. That's for those of you who want to carry out some science or maybe do your own image processing. But Slooh really works like a jukebox. One member is controlling, say, the half-meter telescope like we're doing now, but all of the other members get to see that telescope view live, and everybody can then contribute to the conversation. We always kind of liken it to, we say we're like cavemen and women kind of gathered around a campfire, and we wonder together about the universe and share our great diversity of perspectives. You know, it really is space for everyone here, so please do give it a try, and in the process, you'll be supporting our ability to make programs like this available to the public. Now, don't go away. We will be right back after this short commercial break. Welcome back as we look at this live view from the half-meter telescope at the Slooh Canary Islands Observatory. It's at the Institute of Astrophysics on the top of Mount Tady, 8,000 feet up in the air. You can see a bit of green there on the lower right. That's mainly because we've got you know, some bright moonlight tonight, spoiling the view a little bit. But there it is. There is the star, HD 114762, and the exoplanet that's orbiting that star is called exactly the same thing, but with B on the end of it. We'll talk a little bit more about naming of exoplanets. But, you know, we're making new exoplanet discoveries at an ever increasing rate, as I told you at the beginning. And most of those discoveries are made by seasoned astronomers from a couple of large-scale programs, the Kepler Space Telescope for one. But 4 potential new exoplanets have been discovered by an undergraduate student, Michelle Kunamoto, who only just graduated from the University of British Columbia. And I am so pleased to be joined by Michelle live right now. Michelle, welcome to the show.
Thank you for having me.
You're an absolute inspiration. Your story has no doubt inspired students and amateur astronomers everywhere. You know, and it's this lovely illustration that it's not just you're going to be a professional astronomer, but it's not just professional astronomers who can make major contributions to the science of astronomy. So can you tell me a little bit about how you even started, your studies on this? Was it a suggestion from a lecturer, or was it something you came up with yourself?
So I actually just took my first course on exoplanets for my undergrad degree last year, and I loved the teacher, I loved the topic, and so I was wanting to apply for a research position. And I put that supervisor as my first choice to help me with my research, and I ended up getting that position, and that's the project that he put me on.
Wow. So what did you kind of pin down what it was about exoplanets that kind of really inspired you? What was it that grabbed you about them?
Part of it is just wanted to answer the question, are we alone? And I think planet hunters are actively working towards realizing that, the search for life, finding habitable worlds or potentially habitable worlds. So that's really exciting to be able to contribute to that or have the opportunity to do that.
It is, and we'll be talking about that a little bit later. And if you saw our Transit of Mercury coverage, we interviewed Lisa Kaltenegger. What a wonderful role model she is, and she's so excited that it feels like we are just on the cusp, of really, making that connection between there's an exoplanet and it actually could support life of one kind or another. So anyway, let's go back to the beginning. What did you actually decide to do? How did you start off this whole process?
For searching for the planets.
Yeah.
My supervisor's old PhD student, Jason Rowe, actually was on the original Kepler team. So he wrote a lot of the codes that NASA used. So my supervisor actually just called him up and said, "Hey, I've got this student. She's looking for a project, exoplanet related. Do you have any ideas?" And he suggested that I look through Kepler data just for any planets they might have missed or weren't looking for.
Okay.
So
how do you go about doing that?
Yeah, I used all of the same codes that they did. Actually, it's available for public use on his GitHub page. So I did all the same search routines. I looked at 400 light curves from what are called Kepler objects of interest. So those already had planets or false positives found in them. I think you were just talking about the transit method. So I was using the transit method of finding planets to look through these light curves, look for small dips in the brightness of these stars. And in particular, because I was looking for things that they might have missed, I was trying to keep my eye out for the very, very weak signals.
Okay, and we were talking about this observational bias, a minute ago, where the larger ones are obviously the easier to find. So did you have to kind of redefine some of the algorithm to be able to do this? I mean, it must be a vast quantity of data.
Yeah, I did actually. So what the Kepler team did was they kind of put a threshold below which a signal that was weaker than this signal to noise ratio, they would not explore further because they had thousands of light curves to go through. They just believed there would be too many false alarms in that regime. So I was willing to take the time to actually to go through that noise and just say, well, the real noise threshold is target dependent. So I lowered their threshold a little bit, and some of the planets were in fact in that threshold. So part of these discoveries just shows that there are indeed still planets to be found in Kepler data.
And it is inspirational because it's going back to taking the time, to look a little bit deeper and dig a little bit deeper. That's the story of discovery, surely, for anything. Now, I'm quite interested in what you're planning to do next because of something I read last week. But are you going to maybe dig down into another level of detail? I mean, let's actually, just before we do that, please explain. These are your 4 potential discoveries, aren't they?
Yes.
Can you take us through
So,
what type of exoplanets are they then?
so they've got a pretty big range in sizes. So the smallest one there is KY 205.02. So you were also
Mhm.
talking about naming convention. So the .02
Yes.
means that it was the second transit event found in that light curve, in the light
Okay.
curve KY 205. So that one is actually around Mercury sized, and um, if it becomes a confirmed planet, or even just considering it as a planet candidate, it's one of the smallest candidates found so far in Kepler data.
Wow.
So I've got 2 others, KY 488 and 290. So those ones are around Earth size, just a little bit bigger than Earth. And the one that I'm actually most excited about is the big one that's just a bit larger than Neptune. So that's the one I'm calling a warm Neptune because it's in the habitable
Okay.
zone of its host star.
Now we've got a diagram of that. Maybe you can explain that a little bit for viewers. In the habitable zone. So what does that
Mhm.
mean?
So that's the range of distances from a host star where a planet could have liquid water on its surface. So we believe that liquid water is an essential ingredient for life. So these are the kinds of planets that are most promising for our search for life. Um, so just on a very simple estimation, you could say it's anywhere that the surface of the planet has a temperature between the freezing and the boiling points of water. So based off of my calculations for this planet, its temperature is actually just within a few degrees of Earth's.
Okay. So would we expect, though, to find liquid water on a planet of that size?
We wouldn't.
We wouldn't.
However, if it has, right, it's probably too large. It's probably a lot more like the ice giants or the gas giants of our own
Yeah.
solar system. However, like those giant planets, they have moon systems. So if this planet has a moon in it around it that's large enough to sustain an atmosphere, then that moon would actually be in the habitable zone and could support water. So kind of a pop culture
Okay.
reference is like the planet that they're on in the movie Avatar
Yes, yes, yes,
is
yeah.
actually a moon around a giant planet.
So this brings me on then to my next question, because just by chance I was reading, I don't know where it was even, a new book, and it was talking about the possibility that we may, using the transit method, be able to identify a very short dip just before the actual planet's light curve starts to go down, just before its transit of maybe a moon. So is this something that
Mhm.
you're considering maybe doing and delving even deeper into that Kepler data to maybe try and identify these minor blips that may actually be the signal of a moon?
Yeah, that's a really good idea, and that is definitely possible with the transit method. For my particular planet, it's again it was a very weak signal, so I haven't looked for a moon signal, but I would imagine that you
Okay.
wouldn't be able to see it because those are even smaller than planets, so they will be extremely hard to find in using the transit method or in any light curve.
Well, you came up with this lovely analogy that I saw written, that the Kepler team are kind of standing in a room with a load of people talking,
Hmm.
and they're just listening out for the loudest people. But what you did was you went into that party and you wanted to listen to the person sitting on the other side of the room who was just talking quietly. I think the moon analogy would be you'd then be kind of listening for a mouse squeaking on the other side of the room. You know, it's going to be incredibly difficult.
Hmm.
But, you know, you've shown the patience and tenacity, which is so often rewarded with discoveries. So what are you planning on next? I mean, you go back to college in September?
Yes, I'll be starting my master's degree in astronomy also at UBC with the same supervisor.
Excellent.
That'll be in September. And I'm really hoping to do more exoplanet research. I'm not sure um, what realm of exoplanet research, probably not continuing my search, at least as the main focus, because that was my undergraduate thesis.
Yeah.
But I could always do it in the background. There's still there's thousands of light curves I could still look through.
Wow, you are an absolute inspiration to us. I'm so glad it kind of made the headlines, you know, because there's a whole bunch of us out there who are not studying to be professional astronomers, but, you know, just get inspired by somebody like you. So, Michelle, thank you so much for joining us tonight. We wish you all the best on your return to college, and hopefully you'll be able to come back maybe in a year's time with something totally different that you've hit the headlines for.
We'll see. Thank you.
Listen, just before we let you go, we always like to ask our guests what it was that originally inspired them to get an interest in astronomy. Some people, it was just a sci-fi show on TV that they watched as a kid. Other people, it was a book they picked up, or maybe a really cool teacher. But what was it that inspired your interest in astronomy and science?
I know the exact year. It was in my 9th grade of high school. My dad introduced my brother and I to the original series of Star Trek. And
Oh, brilliant.
Yeah, the original series. A lot of people say, expect people my age to know the Next Generation, so they're usually kind of surprised. But yeah, it was the original series, and I fell in love with it. It was so ahead of its time, and so much of it has this theme of curiosity and human exploration of other planets, and I always wanted to find my own Class M planet. So that was definitely part of it. And around the same time, I was taking the astronomy unit in high school. So that was the only time in high school they actually taught astronomy, was in Science 9. And I had a great teacher there too. And it was just all put together.
So
I
the two
was
of those
convinced
together
I wanted to go into a career.
Was the spark. So, Michelle, thank you so much for joining us tonight. I'm sure we'll see you again in the future as you make even more discoveries. So good luck.
Thank you.
Okay, bye. That was Michelle Kunamoto from the University of British Columbia. What a fabulous example of the kind of contribution both students and amateur astronomers can still make to this wonderful and exciting science. Oh, I always get really excited. Look, we're looking at the constellation camera. Now, this is looking at the constellation of Sagittarius. And it is where one of the earliest discoveries, exoplanet discoveries, lay. We will talk about that one a little bit later. Now, coming up next, we have been talking kind of a lot about the possibility of alien life out there in the universe. And we've been doing it for good reason. You know, we as humans, well, we kind of love the idea of aliens, don't we? I think Lisa Kaltenegger as well, I think she was inspired, wasn't she, by, I think she said Star Trek as well. I heard that. I think got her sitting down watching the original series, so there's a nice little common thread there. But anyway, we love the idea, don't we, of aliens. July 4th, Independence Day, new film. But anyway, so I digress. We are going to have a little bit of fun, and we're going to talk to a cartoonist who writes an incredibly entertaining web comic called The Grey Zone, all about aliens learning a little bit more about the weird occupants of a planet we call Earth. But before we take a commercial break, I want to remind you of a couple of really big shows we have coming up here at Slooh on Monday, June 20th at 8 p.m. Eastern Time. We are going to witness a rare event as the full moon rises on the same day as the June solstice for the first time in nearly 70 years. That's going to be alongside our partners at the Science Channel, so we're really looking forward to that. We are also teaming up with the Old Farmer's Almanac to dive into that rare event and to learn how the solstice has been an important part of human culture for millennia. And then our second show that we're really looking forward to is June 30th. We are celebrating Asteroid Day by taking a really great look back at over 12 years of Slooh's biggest and best asteroid tracking broadcasts. We really were the first people to be shouting about this to raise the profile, as well as looking to the future of what we consider is a little discussed, far greater threat to life on Earth. We will also find out what NASA, along with some private companies, are doing to protect us from the risk of asteroids. And we'll also look to the future to discover what good might come from tracking asteroids. or if asteroids are really the threat we should be focused on. Now, don't go away. We will be right back after this short commercial break. We love celestial equipment. We have spent most of this broadcast talking about other planets far from our own. But now I want to talk a little about the possibility of life on those planets. Humans, as I said, have been fascinated by the idea of alien life somewhere out there trying to contact us here on Earth. From Orson Welles' War of the Worlds radio broadcast, I can't quite remember that one, to the infamous Roswell incident, and through to nearly every form of science fiction and conspiracy theory out there, we have been preoccupied with the thought of alien visitation. We wonder about their lives and cultures, but how would they react to ours? Well, right now I want to welcome Roger Phillips, who writes a webcomic about that very subject. It's called The Grey Zone, and I recommend you take a look at this after the show. It's at greyzonecomics.com. Don't go there until after the show. Welcome to Slooh, Roger. Hi.
Hi, Paul. Nice to meet you.
And you. Now, I was sitting next to my dog on the sofa this evening, and we were browsing the site, and I won't give anything away for visitors to the site, but today's comic was particularly appropriate, especially because my dog quite enjoys what we call cat truffles. But anyway, tell me a little bit about your webcomic, which is absolutely fabulous. We so enjoy it.
Oh, thank you so much. So as you could see, it's has to do with the little gray guys, the little gray aliens, and they are a subject that I was always interested in. But I came from an art background, not like that impressive young woman, you know, with that science background, and this is kind of a hard act to follow. And you know, I took that subject of the aliens, and then I applied it to my influences, which is, I don't know if your audience would know Gary Larson in The Grey Zone. I'm sorry, The Far Side. And things like Mad Magazine, The New Yorker. And that was, I always wanted to be a cartoonist, and I loved the topics of the aliens, and then I combined the two, and then here we are.
So it was a bit of a no-brainer, was it, to just go for aliens from the outset?
It really was. You know, I was looking for a topic, and my father and I had seen the famous UFO in the Hudson Valley in New York. It was that boomerang-shaped object, and it literally flew over our house. And then we were kids in high school, and all the kids ran out, and we looked at it. And you know, 30 years later, I was looking for a subject matter to go with, and my dad said, "What about aliens?" And I said, "Okay, that sounds great."
Yeah. Go with something that, you know, we've got some fabulous examples coming up on the screen. So do excuse me if I get if I lose track of the interview and I just, sit here laughing and giggling to myself. But what is it, do you think then, about aliens and alien visitation that kind of fascinates us humans? Why do you think we're so preoccupied with it in pop culture?
I think that we look at them as they are the next step of human evolution. So they are free of all our, tendencies to be violent or greedy or jealous. And they are, they have perfect intelligence. They are very logical in their approach to everything. And I take off on that notion and then put them in very silly circumstances. So it seems absurd that these perfect beings would, have trouble with opening a beer can or buying a home or something very simple like that. So that little paradox I think seems to work with the strip.
And this idea of, giving us their perspective on Earth, when did that one kind of hit your brain cells?
The first thing when I think about them, I do think, you mentioned this, Roswell in 1947. So You know what's interesting is that you mentioned that, and then the comic strip does well in the United States, where I'm from, and does equally well outside of the U.S. And I spoke to some people who like the strip, and they said it is such an American idea. Isn't that strange that the little grays are
Really?
so Americana, like Elvis, Apple Pie, and Chevrolet, because it happened in New Mexico, you know, right after World War II. And it really resonates with people all over the world, that this, you know, coming together of these advanced beings and, you know, human beings right here on the earth.
I love the moon pies, by the way. You were mentioning apple pies, and it popped up on the
And there's
screen
moon
just
pies
as
right
you
there,
were
perfect.
I mean, I love the artwork, but you know, Roger, your humor is just, it hits my funny bone right
Oh,
right
I'm
on the
glad to
right
hear
spot.
that.
How close are you to being able to fulfill your ambition to make this full time?
You know, I feel like, you know, I always have that one more yard to go. So I've been doing it for about 5 years. I'm about 2,000 strips into it. You know, I had a real grown-up job, you know, for 20 years, and then I always, in the back of my mind, wanted to be a cartoonist. I don't know why, but cartoonist. Astronomer was number 2, but I had
Oh,
more of
okay.
an aptitude for this. And I feel like I'm on the cusp. You know, social media allows unknown people like myself to reach a broader audience,
Yeah,
and
huge
shows
audience.
like yours, of course. And I hope to find a publisher or a syndication company that would, you know, take it to be mainstream, and then I could sit home and just use my Sharpies and then, you know, get a paycheck at the end of the week.
Absolutely. That's the dream of all of us, isn't it? Doing something
Yeah.
that we love and getting a paycheck for it. But, you know, we're certainly going to do our bit, Roger, to get you and your fabulous comic out there as much as possible. You know,
Oh, I
we a
appreciate
couple
it.
of us in the office, we visit every day, and we are still, you know, it's kind of like catching up with a really good series on TV, but you only find out about it on series 4. So you've got this great
Yes.
back catalogue to watch. So you know,
Go
you
back.
said you got 2,000 of these that people
2,000.
can catch up on. So
Yeah,
a
and they're
great
all
one
online.
actually
You
for
know.
absolutely great one for amateur astronomers. If it's cloudy outside, hop over to the grey zone and go through some of the back catalogue.
I hope they do. I think they'll enjoy it. The feedback's been great. You know, people from all walks of life seem to like it. So hopefully it'll resonate with a larger audience someday.
Yeah, it's absolutely brilliant. Roger, thank you so much for joining us tonight. And, you know, let's cross fingers that you get picked up in a big way so that you can do what you love and do brilliantly.
I love that. Thank you so much, Paul. Maybe I'll come back someday with some good news.
We would love that. Thanks, Roger. That was Roger Phillips. I'm sorry if my cheeks are aching because I was watching too many of them on the screen and probably not paying as much attention as I should have done to him. You've got to check out Roger's website, grayzonecomics.com. It's got the strapline Close Encounters of a Funny Kind. Really excellent. We love it. We have got a great segment coming up after this short commercial break. There's the constellation cam. Oh, we've got the Milky Way. The moon is disappearing now, so the Milky Way is starting to pop out. Don't forget, Slooh members, you can be snapping these images using the StarShare camera. We're going to be using this constellation camera a lot more. We're even considering putting one of these on every single one of the other telescopes to kind of give you the context of what you're saying. We're going to talk about the context as well when we come back a little bit later with Bob Berman and Eric Edelman about how far these things are, these stars with exoplanets that we've discovered. But anyway, that is, as I say, going to be coming up. Bob Berman, astronomy magazine columnist and Slooh astronomer, will be joining us. But we also want to hear your thoughts, so just tweet those to @Slooh or use the chat feature on the live channel. At Slooh. We will be right back after this short commercial break. back to the show. Celestron telescope is my second telescope I ever owned. Bought an old C14, 14-inch Celestron. Lovely telescope. I took it to pieces and fitted it with fans and all sorts of stuff. Lovely telescope. Anyway, let's welcome back Slooh astronomer Eric Edelman to the show. Hey, Eric. I can't hear Eric. Maybe we can sort that out. But Bob Berman, Slooh astronomer and Astronomy Magazine columnist, you're also with us. Hey, Bob.
Hey, Paul. Good to see you.
Have you guys actually gone to Roger's website? Have you seen Grey Zone?
I'm going to need to now.
You've got to. But I warn you, don't do it tonight, right? Do it when you get up in the morning, because if you do it tonight, you won't be able to get up for work in the morning because you'll still be looking at it at about 7 in the morning. It's just so funny. It will hit all of your funny spots. It's incredibly clever. Now, Bob, thank you very much for joining us on the show. It's, you know, this kind of stuff is right up your alley, really, because your column in Astronomy Magazine is Strange Universe, and you talk a lot about the weird and the wonderful. And like me, we've got Astronomy Magazine readers joining us tonight. I'm sure, like a lot of them, it's the first page I turn to. I'm a subscriber. What motivates you to? Where do you find your strange universe stories?
Oh, I don't know. Well, you know, as proof that we don't rehearse these ahead of time, that this is really live, I had no idea that question was coming. And first with Discover magazine since the 1980s, and now with astronomy, goodness knows where, after all these decades, that there can be fresh ideas every month. I'm thankful that they pop into my brain. I don't know where they come from.
Well, what I find remarkable is that they're just so different. I mean, it's just eclectic. Anyway, if Slooh members out there, you know, if you guys don't read Bob's column in Astronomy Magazine, make sure you do. And Astronomy Magazine readers out there, if you're not a member of the Slooh community, then make sure you join that. We need to get these two communities together. Now, Bob, this is what we're looking at the moment. 51 Pegasi b. It's that bright star there in our field with the half-meter telescope. Can you tell us a little bit about 51 Pegasi b?
Oh yeah, well that was the big one that really kind of got it started. I mean, we all know that there were exoplanets before that and hints of them. Peter van de Kamp, when I went to school, I won't even tell you what decade that was, but he was all the rage. He was a Dutch-born astronomer who claimed that he was detecting wiggles, radial velocity, in stars like Barnard's star, one of the closest stars at 6 light years, in Lalande 21185, very close star, only 8 light years away, and he was insisting he was seeing those things. So he's getting us all excited back in the 60s. Uh-oh, I let that slip. So yeah, exoplanets were really exciting. But 51 Pegasi, that, you know, that nailed it. That was 1995, and now we knew for sure that there were planets out there. Now, subsequently, finding first hundreds and now thousands, frankly, you know, we're very excited about it, but it's mostly the public. If you talk to professional astronomers and say, what turns you on? What's exciting? As I do, for example, when I'm in Chile each year, you know what they'll tell me? Well, here we're studying dark matter to see the ratio between baryonic matter, that is the known matter in the universe, and mysterious dark matter. Why does it vary from galaxy to galaxy? And are the two in the same place? And does it even exist? Or is it gravity itself that's strange, that falls off strangely at low levels? So that we have to re-examine gravity. And what are these things streaming from the galaxy M82? Is that dark matter that's causing it? So, but the public doesn't know about these things. They care about, we live on a planet, so they care about planets. We're a life form. Most of our readers are life forms. We're life forms, so we care about, are there other life forms out there? Now, the truth is, Paul, as you and I know, now that we know that there's planets, probably every star has planets. There's billions of planets in the Milky Way. What are we left with since we can't visit them? We're not going to be able to go out there. Do we know more about other life? No, not until we detect other life. Radio transmissions, like our friend Seth Shostak does at SETI. Until we do that, we're guessing, we're speculating.
Yeah.
That's all we're doing. We're doing the same stuff we did 100 years ago. Now, some in the public love this, guessing whether there's life. Some astronomers really don't care about it because there's so much hardcore stuff that we can really sink our teeth into. Why should we just keep guessing? And in fact, the habitable zone, I loved what Eric was talking about earlier, the methods of detecting planets. We're assuming that exoplanets will exist in this zone from their star where liquid water could exist on the surface. But where else would there be life in our solar system? Out of the habitable zone.
Absolutely, on the moons. And this is something that I'd like to talk about a little bit, actually, with Eric. We've just seen that live view of 51 Pegasi b. By the way, there are no, we said we were going to talk about the naming of these things. There's no exoplanet with the letter A, is there? They start with B, all of them. But when you see this live image using the half-meter telescope and then the artist illustration, what kind of things does it picture up in your mind? Because to me, it was exactly what Bob was talking about. There's this gas giant planet. It's not the planet that I'm thinking about. It's the moons orbiting it. Are you the same?
I mean, there's just so much that you can be thinking about with all this stuff, because we see, just like you said, that bright spot. And then there's an endless amount of possibilities. We get the data in that comes in, and then the artists supplement it with what we're seeing here. One of the things that absolutely amazes me about the system is that this planet, 51 Peg B, is orbiting its host star every 4.5 Earth days. Like a year there, we would age so fast if we were on that planet. There's just so much to discover. So my mind honestly goes every which way. And I cannot wait every day for the newest discovery, because there's always something new and fantastic that's being talked about. Liquid diamond, planets larger than we could imagine in our own solar system, planets smaller than Mercury. The list goes on and on and on.
Let's hone in on this issue of life elsewhere. As Bob was saying, even in our own solar system, we haven't found a second source of life. But it was this thing that I was reading the other day, and Bob, we were talking on a previous show, weren't we, on the Saturn opposition show, and also Jupiter as well, about life on those moons, and frankly the likelihood that those are our best bets, some of these moons. And we're almost talking here about some of these giant planets having their own and generating their own habitable zones around them. And this is a lot of this is about the tidal forces, isn't it? That the larger planet creates on the moon, which is generating heat, which is giving you potentially liquid water. What are the other drivers that make life a big possibility on these satellites?
Well, that's what it is. We're looking for water. Obviously, life started in Earth's ocean, so you're looking for water. As soon as there's water, you know what the temperature is, because liquid water exists in such a narrow range. So you said it, tidal forces. Now on Europa, because the moons of Jupiter, the Galilean satellites, are like a marching band, and they're absolutely in sync with each other, at least the first three are, whereas every single time Ganymede goes around Jupiter once, Europa goes around twice, and Io goes around 4 times. And because they're always in sync, there is a reliable tidal squeezing of Europa from outside and from inside. Plus, it's so close to Jupiter, with the 317 times more mass than the Earth has, that this poor body is constantly being deformed and squeezed, and this supplies the heat. So here you have saltwater oceans. You have comets that have carried all the amino acids onto Europa, more comets than have even hit Earth over the years. And you'd have to say that if there is not life in those protected saltwater, warm, amino acid drenched oceans, then we have to really rethink the likelihood of life elsewhere. And it really could be then that Earth is the site of a miracle, that this is not a common thing the way we assume. Because if you had a bet, wouldn't you bet that on Enceladus, Saturn's moon, that is spewing 50 tons of water an hour into space, or is it 1,000 tons? No, I think it's 1,000 tons of water per hour. We watch it happen. Boom, water just spewing like Old Faithful into space. Enceladus, we've got Europa, we've got probably Ganymede as well. So we've got it right here in the solar system. Now, someday, not too far in the future, we're going to send probes that will drill or burn their way through the ice and check out what, if anything, is swimming in those warm seas. And if we find no life at all, that's going to be more instructive almost than finding life.
Yeah, well, and I think maybe a little bit scarier. We'll talk about that maybe in a sec. We've got Justin W. In chat, and he's asking us if any of us have UFO stories. Now, I have one, but Eric, I'll come to you first. Have you got any UFO sightings?
Oh no! Oh no! The president told me not to talk about him. No, I don't think I really have. I mean, my closest mark would be just sort of the awe I felt in a meteor shower, seeing that streak of light across the sky. I haven't seen the streak of light land down on the planet per se, but maybe one of these days we'll see.
Okay, well, my one was Justin. My one was when I was about 13. I used to do this early morning paper round. Used to be 4 miles, and I can remember riding down this very long straight road and seeing an incredibly bright light on the horizon. And what was peculiar about it was it just looked like it was jumping up and down and around. And I think actually it was Lisa Kaltenegger on our Transit of Mercury show said that she'd seen something very similar, and it was Venus, but it was her motion that was causing this optical effect that made it look like it was jumping in all sorts of different directions. Now, I'm a pilot, Bob's a pilot. Bob, pilots report UFOs all the time, and I think we need to open up, be more open about talking about UFOs, unidentified flying objects. We're not saying they're aliens inside, but they are. They're unidentified, and military pilots and commercial pilots see this all the time. Bob, have you ever seen anything strange that you couldn't account for in the sky?
No, I have to tell you, it's one of the reasons it's unfair that we astronomers are generally being deliberately ignored by these aliens, that in all these, 2,100 hours of flying, a lot of it night flying, I've not ever seen anything unexplained, and certainly watching the sky all my life. And so this is what makes me skeptical. But Paul, I was out here on the country road. You know how dark my skies are here with my friend Matt Francis last year, who was the director of Prescott Observatory. And what we saw that night was, after a loud roar, obviously a military plane with no lights on and with just a little green something on it flew low, and I mean maybe 500 feet above us, through the valley in which I live. The population of my town is 200 people. This is rural. So this came by, and then within about 5 seconds, an aircraft after it, following after it, closely behind it, also pitch black. And they're not, they're not supposed to be doing this, flying low, even below mountaintop level in an area like this. So I can understand anyone from mistaking this Venus regular aircraft when the landing lights are heading towards you. Jimmy Carter, who was a nuclear engineer, reported a UFO that proved to be Venus. And in World War II, a squadron of I think it was B-29s returning from a bombing mission over Japan, saw a bright light that kept pace with them, and they turned around and tried, unsuccessfully, to shoot down Venus. So even pilots get mistaken by these things. And I'm not saying they don't exist. I'm just saying that, come on, you aliens, it's time. Show yourselves to us astronomers so that we can advertise you. We can tell you that you're real.
This is, one of the biggest mysteries when we're talking about all of this. We've already said that, we started off by looking at the all-sky camera and seeing the multitude of stars. I mean, just look at this single field of view from the half-meter telescope. It's not even a degree across. And we're seeing a multitude of stars there. And I think Pegasi 51 is less than 100 light years away. We now know with this kind of discovery rate of exoplanets, that probably the vast majority of the stars that we're seeing in the skies have solar systems of one kind or another. Whether or not they then contain rocky planets like our own in the star's habitable zone, or whether or not those hot Jupiters and the hot warm Neptunes have moons that are containing, you know, all of that life, where is it? That's always the question. If it is everywhere, then why haven't we been visited with some degree of certainty, you know? So what do you guys make of that,
That would be an
Eric?
argument for life being rare. On the other hand, maybe we're not being imaginative enough. As you know, increasing physics is showing us that observation, when we make an observation, we create the reality, that electrons only exist probabilistically. They pop into existence and leave behind, this was John Bell's work in the 60s. They leave behind their sort of probability state, their wave function collapses upon observation. So it may be very possible that we and the cosmos are correlative. We go together. We as observers, in a way, create the cosmos. We are created by the cosmos. In other words, there's a single unitary thing happening, and therefore life would be part and parcel of it all. There actually would not be anything that's not part of life in the universe. I mean, there's all sorts of ways that this may go far beyond the perhaps limited way that we're discussing this so far.
Well, what do you think about this, Eric? This dichotomy of, you know, it should be out there everywhere, but why haven't we been visited? Have you got any views on that?
I mean, I think there's this wonderful image, I don't know if we have it here, of how far our radio waves have gone into space since the advent of our time communicating with ourselves. And it's a dismally small percentage of our own Milky Way galaxy. And so in terms of maybe other species observing their parts of the galaxy, trying to see if there is other intelligent life out there, maybe we might not look like intelligent life to them just yet. Maybe we need to be established for millions of years for the Galactic Federation to deem it worthy to try and visit Earth and see what's going on there. I think that maybe there's still a potential, but that we just haven't seemed habitable just yet, perhaps.
Yeah,
Ricardo
one of the things
Montalban.
that goes through my mind with all of this is, even if you look at the history of life on Earth, you know, you've got the dinosaurs reigning for all that period of time with no technology, right? They're not going to be sending or receiving any radio kind of broadcasts from anyone. They were intelligent, but not as in the search for extraterrestrial intelligent life, you know. And if it wasn't for that big asteroid that came down and knocked them for 6, then they'd still be here. I mean, they were on the Earth, you know, far, far longer by huge factors beyond humankind. I mean, what do you make of that, Bob, before we wrap up?
Okay, let's take that ball and run with it. You know, forget about the little tiny brain stegosaurus. Let's take the creatures today that have great intelligence, whales, especially dolphins. They show no inclination to leave the oceans or to hurl themselves into space or to build metallic spaceship or communicate by with electromagnetic radiation. So it's certainly possible, especially since you brought up the topic of where are they? Why haven't we heard anything? Maybe they are closer to the norm than we are. Maybe creatures with more peace of mind find no need to be restless enough to do this kind of thing, to want to leave their homes. Maybe this is just kind of our shtick, and it would be extraordinarily rare. I'm talking about 1 in a billion for intelligent life forms to even bother leaving their own environment, and we just assume they would, and they work.
And we've also been talking.
This is more
we've
guesswork. That's what we're back to this again, speculating.
Yeah, we've got to wrap up now. But you know, it also goes back to, you know, us thinking about where these exoplanets are within their solar systems and the habitable zones. That potentially, it's the icy moons, which are the thing that contain that liquid water. They have no surface on them in the same way as a rocky planet does, and it's pretty darn difficult to develop technology, I would suggest, underwater. Maybe that's why dolphins don't have iPads.
Uh-huh.
I don't.
Hadn't thought about it. In other words, you got
Anyway,
to play
gentlemen.
with the tools at hand. Yeah.
Gentlemen, we've got to wind up now. It's been an absolute. We've got to do this more. We wanted to do this more and more actually, and I think we'll get into the flow of it when three of us are on. We're still looking at this great shot of the Milky Way stretching up through the sky over the Canary Islands. I think the moon's gone down now, so we should be good for some faint nebulae and faint galaxies. But thank you so much for joining us both tonight. Thank you, Eric, for bringing your expertise with exoplanets. I know it's a great love of yours, and your shows. If Slooh members have not seen your Down to Earth shows yet, they have got to pick them up. They are so entertaining and informative. I'm a fan.
Thank you. Thanks for
Bob,
having me on.
Thank you. Bob, thank you so much. It's always a pleasure to have you on. As I say, your astronomy magazine readers should come over and join the Slooh community, and any Slooh community member who doesn't yet read the Strange Universe column in Astronomy magazine, they need to make sure they pick up a subscription to that. So thank you very much, Bob, for joining us tonight.
Thanks, Paul. And Eric, a pleasure. It was really good listening to you.
Yeah, it's great. Wow. Isn't it great always to hear from Bob and Eric? You really do have to catch Eric's Down to Earth show. That's on every Tuesday at 9 p.m. Eastern. And of course, Bob does his show for Slooh members every Tuesday and Thursday nights, and that's 6 until 7 p.m. Eastern. Wow, what a show. We've overrun. We could have gone for a lot longer. I think we were just getting into our stride there. But anyway, what an inspiring story we heard from University of British Columbia student Michelle Kunamoto. Let's cross fingers her discoveries are confirmed, and we wish her many more in whatever field she chooses to go into next. And of course, Roger Phillips, creator of the Grey Zone web comic. You really should check that out. You need to do so tomorrow, because you will not stop reading those. Highly entertaining. Before we leave tonight, I want to tell you, I want to tell any Slooh members who are interested in joining the new Variable Star group and learning all about photometry with the Slooh telescopes, just check out the new group that's been posted in the Clubhouse. So lots of members are showing a big interest in doing that. It's so also the course that we're developing is also good for tracking and monitoring comets and asteroids as well. I also wanted to remind you about a couple of exciting shows we've got coming up here at Slooh on Monday, June 20th, 8 p.m. Eastern. We will witness a rare event as the full moon rises on the same day as the June solstice for the first time in nearly 70 years. That's going to be alongside our partners at the Science Channel. Looking forward to that. We're also teaming up with the Old Farmer's Almanac to dive into that rare event and to learn how the solstice has been an important part of human culture for millennia. Then on June 30th, we are celebrating Asteroid Day here at Slooh by taking a look back over 12 years of Slooh's biggest and best asteroid tracking broadcasts, as well as looking to the future of what we consider is a little discussed far greater threat to life on Earth. We will also find out what NASA, along with some private companies, are doing to protect us from the risk of asteroids. And we'll look into the future to discover what might become from tracking those asteroids, or if asteroids are really the threat we should be focused on. We're still looking at this live image from the half-meter telescope of 51 Pegasi b, that star with the exoplanet orbiting. I hope you've enjoyed our exoplanet show tonight. We're going to be delving in more depth into some of these shows later on. You know, at the moment we're kind of doing them fairly general, but we're going to be picking up a whole series of different shows on different themes. So do make your suggestions to us. But that's it for tonight. We hope you've enjoyed the show, and we will see you very soon. Good night for now.